All right, so we're officially starting chapter one. Well, technically, we'll start chapter one on Monday. We're doing the introduction part of the textbook today and tomorrow. Okay, students received the chapter one packet with all of the assignments listed and then the resource pages for all of the sections, and we are ready to get going. Okay, the first goal for today. So again, a lot of people already provided things like test scores and ages and money, and I had examples like that kind of pre-printed, but I loved the extra context that some of you gave. The point here is, again, numbers by themselves are meaningless. You need context. Now, the other thing that I think is kind of interesting, I really liked this last example. Again, I can't take credit for it. It's something a former student came up with. They treat it as counts of a type of animal on farm, like 17 cows, 21 chickens, 44 sheep. The reason I really liked that is because most people, myself included, put themselves in this box of assuming that these numbers are quantitative. But that person treated it as if they were records of a categorical variable. And that's a perfect segue into the first thing that I want to talk about today. You have to be able to decide what type of variable you're dealing with. Okay, is it quantitative or is it categorical? Now I'm going to show you a couple examples and then we'll go through a couple problems in the book itself. But this decision of what type of data am I working with is really critical to a number of things. I'll elaborate on that after we do a few problems. Okay, so let me give you an example. One thing I'd like to point out, notice that this page is tinted yellow. That is my way of signaling to you, you're not going to find this in your packet. Okay, so you can just kind of stay right here at this page. There's no reason for you to try to find this. You're not going to find it. So tinted screen, not in your packet. Okay, so let me just show you a couple examples of different variable types. The most boring one, which we will basically never analyze ever, is an identifier. It's a variable that is unique to each individual person. Okay, I realize it's a number, but that doesn't make it quantitative. If I asked you all, what is your student ID number? A really nice way of making this distinction is ask yourself if calculating the mean would tell you anything. And if I got the student ID number of all of you and then calculated the mean of that number, I don't even know what that number would represent in context. Like, what would that even be? So that's one of the pre-type notes that I have for you in your packet. It says the involvement of numbers does not always imply quantitative, because that's a pretty common mistake. Okay. Now, we'll get into some of the more interesting ones, like political view. That was one of the things that was asked on the survey yesterday. That was categorical. Liberal, moderate, conservative, other, I believe, are the options I gave you. Okay. Number of siblings, number of states visited is quantitative. Now, high school grade level is kind of a weird one because it's another one of those situations where it's a number, 9, 10, 11, 12, unless you want to use the words freshman, sophomore, junior, senior. But even though it can be a number, it's categorical. Okay. Now, shoe size is again a number. Age is also quantitative. Notice with age, I provided a unit. That's because number of siblings is just a number. Number of states visited is just a number. Shoe size is just a number. But age is something that needs to be specified. I'll give you a quick example from the previous class. Somebody said that this could represent different times and stopped there. Okay? There's nothing wrong with that. Like, that's a good answer. It could be times. But when he said that, I was like, can you give me a little bit more? And there was a kind of this pause of not really being sure what I meant. And so I was like, all right, well, do you mean seconds, minutes, hour? And he was like, oh, seconds. And it's like in his head, it was just intuitive that he'd be talking about seconds. But what if he was talking about years? Very different. Okay. So if you can provide the units for a quantitative variable, you should. Okay. If you're encountering a quantitative variable, you should want to know what the unit of measure is. Okay. Do you own a pet is another kind of an interesting one because the way it's phrased makes it categorical. Do you own a pet? Well, it's yes or no. That's categorical. But if I change the question and I say, how many pets do you own? Now we're talking about kind of the same data, but in a completely different way, and I've made it quantitative. Okay, so sometimes it's just the way in which you ask a question that can predetermine the type of variable you're collecting. Okay? All right, so we're going to go ahead and take volunteers here if people are willing to. It says the box to the right shows several possible locker numbers at a local high school. Could a student's locker be considered an identifier variable? Would it be possible to consider a student's locker label to be a quantitative and or categorical variable? Explain. Perfect. All right, now, before I reveal, and what Alon just said, I basically agree with everything he talked about. He said it's an identifier because every kid gets their own unique locker. That's not how he phrased it, but that's essentially what he was saying. I saw other people raising their hand as he was speaking, and I just want to clarify the directions allow for the answer to be yes to any one of these or multiple. So don't think that because he said yes to identifier, it's automatically no for the others. Does that make sense? Okay. All right. Sid, I think I saw your hand. I also saw Dylan in the back and Dresden. Sid, I'll start with you. All right, so it's interesting because Sid is giving me definitely the answer I'm looking for, that it could be considered categorical. He's highlighting the letter in the front, and he's clearly not really sure what the letter might represent. And in my old school at Albert Einstein High School, what Dresden just said is exactly it. The main hallway at Einstein is essentially a giant box. It's a rectangle. And depending on which hallway you were in, you were either an A, a B, a C, or a D. Now, the number can also be a category. Does anyone know what I'm talking about? Not any of the last digits, actually. It's the first digit that I'm focusing on, the floor number. Okay. So you could say yes because the letter is like a hallway or a location in the building. Okay. Or you could say the first digit is a floor because that's a pretty common feature. And Einstein has an underground level. It has a basement. So a 0 would be a basement, 1 would be the main level, 2 would be the second floor. Okay. Now for quantitative, the answer is no. And hopefully people can kind of connect the dots to the student ID number example that I already talked about. If I got all your locker numbers and ignoring the letter, if there was a letter, just found the average value of a locker number in this room, that doesn't really tell me a whole lot. Okay, so again, a really good litmus test if you're in that confusing gray area of a number is involved, but it's not really quantitative, then ask yourself, would the mean give me additional information? And if the answer to that question is no, you're probably not dealing with a quantitative variable. Okay? All right. For the sake of time, I'm just going to reveal my answers here. Please don't stress about your answers matching mine perfectly. That's never going to be the expectation. But I want to make sure I save time. There's one other page I want to get to in the note packet today. Okay, so let's be clear, definitely not an identifier. Okay, with a locker number, if you give me a locker number, I could go to the main office and find the person that connects to, because each person has their own locker number. But if you give me a GPA like, hey, this student has a 3.1, that doesn't tell me who they are because there's a bunch of people that fit that description. Okay, so that value can repeat. It's not an identifier. Now, it's certainly quantitative because if I get a group of kids and I calculate the mean GPA, that does give me some kind of general information about that group of students. And if I have two separate rooms of students and I get the mean in each room and the average in here is 3.2 and the average in there is 1.7, that definitely tells me something. Okay. Now, in terms of categorical, I will admit I put both yes and no because I wasn't really sure which route you all would want to take. To me, I would just say no. Like it's pretty clear that it's not really categorical in nature. It's just a number. However, you could treat it as categorical if you were defining things like, are you on a roll or not? Or are you eligible or not? So you could use GPA in a way that makes it categorical. And you could just say, tell me your GPA. And based on that, I will categorize you as you are eligible for the honor roll, you are not eligible for honor roll. So you could treat it that way if you really wanted to. Okay, Dylan? Page. If you want to turn the page, go ahead. I'm not ready to get there myself just yet. So far what we've done today is we've identified the difference between a quantitative and a categorical variable. Okay, and the reason this is critical is really two main things that I would talk about right now. Number one, we're going to be looking at a ton of graphical displays. And we're also going to be making graphical displays. You have to know the type of data you're working with to know which type of displays you're allowed to make. Best example I can give that gets confused in the outside world all the time, there is a vast difference between a bar graph and a histogram. And if I'm looking at one or the other, I instantly know whether or not it's a bar graph or a histogram. I also instantly know why it's a bar graph versus a histogram, okay, and vice versa. And that has to do with the type of data. Now, when we get into second semester and we're doing hypothesis testing, we're going to learn a whole bunch of different hypothesis tests that we can be running. And depending on the type of data you're working with, that will guide you in deciding which type of test you're going to run. Okay, so you have to know what you're looking at. Now, the other thing that I want to talk about today, and I had one other example page, but I'm just going to kind of include that in the lecture notes. This is not in your packet. It was just one other example of a chart of possible variables and which ones are quantitative categorical. So that'll be included in the notes on Canvas in case you want an extra exposure to it. But the other thing I want to talk about today is sort of the mentality that I want you all to try to adopt when you are encountering data in your everyday lives. Okay. Now, this is actually an excerpt from the first textbook that I used when I started teaching this class like 16 years ago. Great textbook, but I will admit I was really thrilled when I saw the textbook that Clarksburg used. I felt like this textbook is much better. But the very first year that I taught APSTAT, I've always kind of been a numbers nerd. I have Excel spreadsheets, that track tons of things for my daily life just because I'm a nerd and I like to track numbers on things. Okay. And I realized when I came across this page in my old textbook that this was a really simplistic way of explaining my thought process. When I read this, I was just like, holy moly, like that is literally kind of the thought process I'm going through. If I ever read an article or listen to a news report or watch a YouTube video, if I am ever in a situation where somebody is trying to present me with data to try to convince me of something, my brain immediately starts, before I'm like listening to what they're trying to convince me of, I immediately am thinking, well, when was this data collected? How did you get it? Why did you collect it? What is this person that's talking to me trying to convince me of? Because that could bias the way they collected the data or the way they analyzed the data. There's sort of a thought process. Now, this textbook defined it as the 5 W's and the H: who, what, when, where, why, and how. Okay, so with that in mind, I'm going to do one or two of these and then ask you all to try one yourselves. Okay, so the directions say read each scenario below and identify the W's and the H if possible. Okay, the first thing I want to just point out before I even read the first example is that who does not mean a person. That's a really common mistake that people make. The who is the subject of the data. So an example that's not in front of you, if I was analyzing tomato plants and I wanted to know after a certain number of weeks, how tall did they grow? How many tomatoes did they grow? Okay, the who is the tomato plants. Okay, the what, the variables being recorded in that scenario, would have been the height, presumably in inches or something like that, and the number of tomatoes on the vine. Okay, the what is the variables you're recording. So I just want to be clear, who doesn't necessarily mean a person. All right, in an attempt to inform customers, I know the why. Whatever's happening here, it's because they're trying to inform customers. An article in Consumer Reports magazine was published on energy bars. That's the who. So we're about to be presented with the idea of data collected on energy bars. Okay, the 20 comes in later, but I'll keep reading. Sold in New York City. That's the where. I don't care where this magazine was published. It could have been published in California, but the data was collected in New York City. Okay, in 2018. Back in 2015, okay, now I'm potentially confused. They just said 2 different years. So I got to reread this carefully. It says the labels of 20 random energy bars were used to report brand. All right, so they use the labels on these energy bars. I'm still a little confused on the when, so I got to reread that sentence. But it says reported brand name, flavor, calories, and grams of protein and fat. Now I got a little bit lazy. I just used Q and C for quantitative and categorical. Okay, for categorical, we've got brand name and flavor. For quantitative, if you can provide units, do it. Okay, they said protein and fat was measured in grams, so I provided those units. Calories, if anyone isn't already aware, is its own unit, so you don't need to put a unit attached to that. Let me get back to this. So I mentioned before I was a little confused on the when. Notice the sentence says an article was published in 2018, and then it goes on to say back in 2015, the labels were looked at. I care about when the data was collected. The when is the 2015. This is a really critical thing for you to apply in your real world lives, because I personally have encountered situations where an article was published in 2022, and if you look at the footnotes or the citations down at the bottom, the data or the study that they're referencing was conducted in 2007. It's like 15. You're writing an article today, 2022 at the time, about data that was collected 15 years ago. Now, I'm not saying that's inherently wrong. Like, that's fine. Do that. But the reader should be aware of it. Okay, if you're going to be a critical thinker, you have to pay attention to when the data was collected, not when the article was published. Okay? All right. I'm going to jump all the way down on the bottom, actually. All right, I'm going to read the whole paragraph, reveal what I would have written, and then say, because we've only got about 5 minutes left in the class, just try part B on your own time outside of class. You can check the Canvas notes to see if you did it correctly. Okay, the Cleveland casting plant is a large, highly automated producer of gray and nodular iron automotive casting for Ford Motor Company. According to a 2015 article in Quality Engineering, Cleveland Casting is interested in keeping the pouring temperature of the molten iron in degrees Fahrenheit close to the specified value of 2550 degrees. Cleveland Casting measured the pouring temperature of 10 randomly selected crankshafts. Okay, I finally know the who. We've got these 10 crankshafts. Okay, they collected data by random sample. So that's the how. They took and I'm glad they took a random sample. That'll actually be a really big part of a future unit we take in this class. Experimental design and surveys and studies. Okay, how do you collect data in an unbiased way? That's a great way to do it. Take random samples of 10 crankshafts. Don't get the next 10 off the line. That might be considered a convenience sample, and that opens you up to bias. Okay. The where, I'll admit, maybe the Cleveland casting plant has multiple locations and it's not necessarily in Cleveland, but I'd be fine just saying it's in Cleveland. I mean, that seems intuitive enough. Now, the when is something I'm going to, again, reveal last. The what and the why are kind of connected. They have a sentence that says they're interested in keeping the pouring temperature close to this specified value. So then they measure the pouring temperature. So it's kind of like they're the same. The what is the pouring temperature. The why is they're trying to keep the pouring temperature a certain degree. Now, I risk being a little bit repetitive with the when. This article was published in 2015. That's the only date that was presented. Okay, so if a person were to write for the when, I don't know, or not specified, or unsure, or however you want to say it, I got to, and Dylan, this might be even related to your question earlier. If a person put one of those, I don't know, not told, not specified, I'd give credit for that because that's actually true. But if you wanted to be critical, the best thing I think you could put is just prior to 2015. If the article was published in 2015, well, then the data had to be collected prior to that article. So that's something, but it's more or less you don't even know. Okay? All right. All right, so we're going to end class here. I encourage students to try B on their own time. And here is the answer key. We are done. Thanks for watching. Have a good one.